guys. So today we're starting the day 2 video of lesson 6.4. So we're still going to be on metallic bonding. As we said yesterday, metallic bonds are different from ionic and covalent bonds because of the way that the electrons are arranged inside of them. In an ionic bond, an electron is transferred from one to the other, and that electron stays with this one, and they become positive and negative and they stick together. In a covalent bond, the electrons are shared between two atoms, and in a metallic bond, electrons become delocalized. What that means is that basically electrons can leave the atom and they're free to go wherever they want in the sea of electrons. This happens because they have so many empty orbitals in their outer shell that these empty orbitals overlap and basically fuse together. So the electrons are free to go from this atom to this atom to this atom to this atom, wherever they want to go. All right, so today we're going to get into the properties of metals and what makes them so special and why they have these properties. All right, so chemical bonding is different in metals than it is in ionic, molecular, or covalent networks. By the way, remember, molecular is basically the same thing as covalent. The unique characteristics of metallic bonds are their ability to conduct electricity and heat, and the fact that they are malleable and ductile, and that they have luster. You guys can just look at this and figure out what it's called, and we'll go over why they have all of these properties right now. So, first thing you need to know is that they can conduct electricity. So they have conductivity. This is a very obvious thing. The fact that their electrons are free to move from place to place means that they can carry electrical charge from one area to another. This is why if I attach one half of a wire to a battery and the other half to another part of the battery, an electrical current will run through that wire. Then if I put a light bulb in the middle of it, electricity will actually begin to show itself. This is basically how it works. So you get all of these electrons moving from an area where they are moving towards a positive terminal. But this is only if you actually apply energy to the electrons. Otherwise, they would just move freely in random directions. All right, so pretend that this is a battery. A battery, as you know, always has two little pieces. I'm sure you guys have tried to put batteries in and they went in the wrong way, so you tried to flip them around and see if that worked. This is because batteries have a positive and a negative terminal, and if you put them in the wrong way, they're not going to work properly. So, this is the negative terminal, this is the positive terminal, and electrons will move from the negative terminal towards the positive. And I'm sure you can guess why this is. It's because electrons are negatively charged, so they are attracted towards a positive area. So as you can see, they move from the negative and they move towards the positive. None of the electrons are leaving this system. They are still inside the metal, but applying a battery to this system forces the electrons to start moving in this way because you put this little positive area here and suddenly the electrons want to move. This movement of electron carries charge, which allows you to use electricity. So all the light bulbs in your house are just a result of electrons moving and powering your machines. All right, the next two properties we need to talk about are malleability and ductility. Malleability is basically the ability to hammer something into sheets. This basically means that if you take a metal, it can be bent and flattened in many different ways because of how strong the bonds between the atoms are. If I take something like an ionic compound, like salt, and I hit it with a hammer, it would break into a million pieces because it doesn't have this property. It would not be malleable and it would not be ductile because even though ionic compounds have very strong bonds between their atoms, as soon as you apply a certain amount of energy, they do break apart. While metals keep holding each other so strongly that even if you hit them, basically they'll just slide past each other, but they're not going to fall off of each other. This is why if you hit it with a hammer, you can turn it into a sheet, and if you pull it and pull it and pull it and twist it, you can turn it into wires. This is a very special property of metals. You can't do this with other types of bonds. And this is mainly because of how strong the bonds are between them, okay? Is lustre. I'm sure you guys have already heard this word before because we've discussed it before when we were talking about d orbitals and all of that. Lustre basically means something that is shiny. So, the reason metals have lustre is because metal atoms absorb energy very quickly and emit that energy of a similar frequency very quickly. This gives metal their shine. And almost all frequencies of light are absorbed and emitted by a metal. This is why they're shiny. So the basic idea here is if you absorb a lot of frequencies and you emit a different wavelength, then you're not going to be shiny. You're going to have a color or a texture or something like that. But if you absorb all frequencies of light and you emit all of them basically at the same frequency, that means that you're going to have something that perfectly reflects what is being shown to it. All right? So that is lustre. Now guys, go and do the quiz. Remember today there is no worksheet, so just ignore this. Do the quiz and good luck.